first question in question 3 is asking us to prove that the sum of any geometric sequence can be given by this equation where the first term is a and the common ratio is r. So the first thing that we do is that we can get our terms by saying in geometric sequence we can get our terms by saying Tn is equal to a times r to the power n minus 1. The first term 1 is going to be a. We have our first term. Our second term is going to be a r to the power 2 minus 1. That's a r. Our third term is going to be a r 3 minus 1. A r squared. Our fourth term is going to be a r 4 minus 1. A to the power a times 3. A times r to the power 3. And we can do that for all the terms in the sequence. And since we do not know the number of terms in this sequence, our final term can be expressed as Tn is equal to a r to the power n minus 1. This would be our last term, with n representing any number of terms within any given geometric sequence. We have the value of our first term being a, the value of our final term being a r n minus 1. We can also get the value of the second last term. We can get that by, since we know that our final term is n, we do know that the value that comes before n is one digit less. So n minus 1. If in a given sequence we have 20 terms, our final term is n would be 20. The number before it would be n minus 1, being 20 minus 1, 19. This is what it means. N minus 1 means that the total number of terms minus 1, because it comes before the last term. So Tn minus 1 is going to be a r to the power n minus 1 minus 1. So we then have a r to the power n minus 1 minus 1 is going to give us a r n minus 2. So we have the value of our first term, the value of our last term, and the value of the second last term, a r to the power n minus 1. And then the values of the numbers between these two, and we'll express them as 3 dots. So we're still looking for the sum. What we're going to do is say the sum is going to be the first term plus the second plus the third plus the fourth 2, 3 plus the other values that come between, and then the second last term, which is a r n minus 2, and then the last term, a r n. This is our sum. We're going to express this as our first equation. After this, we're going to say multiply the first equation by the common ratio. So we're going to say this multiplied by r, so that we have r as n is equal to a times r. We're going to be a r plus ar times r is going to be a r squared, because we have ar times r. We have two r's multiplying each other. The exponents are going to be added so that we have a r squared. That's how I have a r squared. And then for this one, I'm going to have a r to the power 3. This one, a r to the power 4 plus many that comes between. And then for this one, we're going to have a r n minus 1, because this is because it's a r n minus 2. If we multiply by r, which has a positive 1, it's going to be a n minus 2 plus 1, negative 2 plus 1, a r n minus 1. That's why I have minus 1. And then for the last one, it's going to be plus a r n. Oh yeah, first. For the last one we'll have a r n minus 1 multiplied by r, which has a positive 1. So we have a n minus 1 plus 1. These two cancel each other out, so that we're left with a n. So here we'll have a to the power n. This will be our second equation. Yes. So from here, we want to subtract the first equation from the second equation. So we're going to say subtract. We already have our second equation. We're going to write down our first equation as n is going to be, we have a, we have a r, we have a r squared, we have a r cubed, plus the a r n minus 2 plus a r n minus 1. We're going to cancel out values that appear on both equations. For instance, a only appears on the second equation, on this equation, so we're not going to cancel it out. AR appears on both. Remove AR squared, remove AR, remove. We're going to continue cancelling everything out until AR n minus 1, AR n minus 1. Everything that is between AR as well as AR n minus 1 is going to cancel each other out, because we're assuming that everything that's between these two that appears between AR as well as AR to the power n minus 1 can be found in both the first and the second equation, such as AR squared is found in both. AR third, we're going to assume AR fourth is also included in this, is going to be included in this, whereas AR n minus 2 is included in this one. So it also cancels each other out. The only thing that we're left with is Sn minus Sn is equal. On top, we're only left with ARn, AR to the power n. At the bottom, we're only left with A minus A. Our common factor, Sn, we're left with R minus 1. Here, A is our common factor, we're left with Rn divided by R minus 1. R minus 1, Sn is equal to A Rn minus 1 over R minus 1. So, for this question, we are asked to determine the value of x if the series will converge. In a geometric sequence, the series will only converge if our common ratio is less than positive 1, but greater than negative 1. One way to find the value of the common ratio is by saying T2 over T1. Over T1. Our second term is going to be 4x minus 2 that's expanded over 2. Then our first term is going to be 8x minus 2. One of the x minus 2 should cancel out. We have 1, 4. Yeah, it can also be expressed as 4 times 2. The 4 cancels out with this one, and then we're left with x minus 2 over 2. This is the value of the common ratio. But to solve for x, we now have to include these inequalities. Positive 1, negative 1. we want x, so the first thing that we're going to do is multiply by 2. By multiplying by 2, we do this on both sides. So in the center, we'll only be left with x minus 2. On this side, we'll be left with 2, negative 2. We want x, we're not looking for x minus 2, so we have to plus 2. But this plus 2, by plus 2 on this side, we have to do it here. We also have to do it on this side, so that we're left with x is less than positive 4, but greater than 0, because negative 2 plus 2 is going to give you 0. So the series will only converge if the x values are between 0 and positive 4. The question that follows is asking, if the value of x is 3.5, calculate the sum of the infinity. We already know that our r is x minus 2 over 2. We can substitute our 3.5 here. 3.5 minus 2 over 2, that's going to be 0.5. That's going to be 1.5 over 2, which is 3.4. This is our ratio. The sum of infinity requires the first term as well as 1 minus r. We can find the value of the first term. It's 8 times x minus 2. We can insert 3.5 here, minus 2. We have 8 times 1.5 is going to be 12. Then we can substitute our 12 here. 1 minus our ratio is 3 over 4. 3 over 4, 12. 12 divided by 1 over 4, which is 12 times 4, that's going to be 48. Therefore, our sum of infinity with alpha, with a being 12 and r being 3.4 is going to be 48.